So coming to the independent sample t-test. So independent sample t-test. So today's session will be again the comparison of mean. So whether it is a 2 group or whether it is more than 2 group. So today we learn the comparison of mean between the 2 group and 2 or more group, about when the data is normally distributed and when the data is not normally distributed. So what will be the research question for these sort of comparison of mean? So like first, if the research question is the new teaching method can improve the mean marks obtained to the students as compared to the institute mean marks, right? The second question could be, is the hemoglobin level of the sample population is same as the national average? The third research question could be, is there any difference in the mean depression level between the sample and the population? So here what you have seen, in all the 3 cases, there is one continuous data, because now again the concept of variable will come. If we see the mean marks, what type of variable it is? Like if I say the mean marks is 70, 75, 80, what type of variable it is? You can type in the chat box. We have seen 4 types of data: nominal, ordinal, interval, ratio. So quantitative, yes, Darshana is saying yes, scale variable, that is good, or ratio, that is also good, because if somebody has got 7 or somebody has got 14, we can say that the 14 is twice as 7. So yes, you are very right. To be more precise, it is a ratio. But if you want to be like, clubbing the categories together, like interval and ratio, then you can call it as a scale variable also, because SPSS recognizes both these variables as a scale variable. So you are right. So here is a variable. In the second case, hemoglobin level, what type of variable it is? The hemoglobin level, we can say that it is 11.2, 11.3, 12, 7. What type of, again, quantitative? Yes, you are right. Scale, yes, that is also right. And if I go for this, like we have discussed the 2 type of quantitative also, the continuous and discrete. So between these 2, what type of this thing? Is it a discrete one or is it a continuous one? Yes, so Aliza is right. It is a continuous, because discrete, because fractional values are possible. So it is a continuous data. So in all these cases, the third one also, the mean depression level. Here the mean depression level I am assessing with a score. So there are various tools for assessment of depression. There's a Beck depression tool. There is a PHQ-9. So if I am assessing the depression with a score, then again it is a type of continuous data. So in all these 3 cases, you are seeing that it is a continuous data, which I want to test the mean of that data against a known mean. So can you see the analogy of this with the goodness of fit test, which we did yesterday, where we test one proportion against a known proportion or a hypothesized proportion? Can you find a similarity? The difference is only in terms of the type of data. In the goodness of fit, we were testing the proportion. And in one sample, this is a one sample t-test. Here we are testing a mean. Otherwise, the concept is same. So because there is a single variable, and we want to test that variable against a known mean. So in all this case, what have you observed? That we are testing a scale variable in question, and we want to compare this with the population where the average is either known or it is hypothesized. So you are right. This is again a appropriate statistical test will be to check whether there is any difference in the average score of the scale variable against a known or hypothesized value. And the sample or the test which is suitable for such type of research question is the one sample t-test. The one sample t-test is also known as the single sample t-test, single parameter t-test. I think it's or the one sample t-test. So there are few underlying assumptions. In chi-square also, we read about the underlying assumptions. So I said initially also in the beginning also that before we apply any test, we need to check the underlying assumption, because if those underlying assumptions are met, then only that particular test is a suitable test for your data. So now what are the underlying assumption for one sample t-test? So the underlying assumption is there will be one dependent variable which is measured in a continuous scale, like you have seen, the mean depression score, mean hemoglobin, etc. So that is on the continuous scale. The second assumption is variable should be approximately normally distributed. So we are saying approximately. We are not saying it should be very stringently or totally distributed, because there can be a little bit deviations. That's why we have added the term approximately normally distributed. And the third is there should be no significant outlier. There may be outlier, but it should not be very much large in number. So we say that there should be no significant outlier. So these are the three assumptions of a one sample t-test. Coming to the concept of outlier, can you recall the first session of descriptive where we did the explore and statistics option? Yes, Ashish, I'm coming to that significant outlier. Next, this outlier will answer your question. So can you recall the session on descriptive where I have shown you the explore? We have seen the statistics where we saw the trim mean, the kurtosis, the 95% confidence interval, and etc. So there you have seen the extreme values, but in that session also I reiterated that these extreme values are not the significant outlier. Now, how to define outlier? So there are two types of outlier: simple outlier and extreme outlier. So the simple outlier is when the data point, it is more than 1.5 box length from the edge of their box, are classified by the SPSS statistics as outlier, which is shown as a dot. So if you see this, in the first one, there is no outlier because there is no data point which is showing you a dot. In the second one, you can see that this case number 16 or the case number 23 or case number 126, these are outlier because this is represented by a dot. And if you see the value, it will be 1.5 box length from this edge of the box plot. So the distance between this edge and this will be more than 1.5 box plot. So that the SPSS characterizes as outlier. Now the second concept is about the extreme outlier. So the data point which are 3 box length away from the edge of the box plot. So like if you see this case number 173, this is 3 box plot from this edge of the box plot. So if you see this, so what we can say that this 173, it is a extreme outlier because it is represented here by an star. Okay. And this 173, if you see, this is a case number. This is not the value. So don't confuse the number here with the value. This 18, 23, 126, these are the case ID or the serial number. These are not the values, right? So in the third graph, you can see there are many outliers. So all these stars and all these, if you see this, so all these values, these are they form the outlier. If you see this, and even if you see this, this is also an outlier, right? So this is the concept of extreme outlier and normal outlier. So extreme outlier are represented by asterisks. They are more than 3 box plot from the edge of their box plot, and the outlier are more than 1.5 box plot from the edge of the box plot, and they are represented by a circular dot. So this was the concept of outlier. Now, what could be the reasons for? So Ashish, did you get your answer? How do we define significant outlier? We will see it in the data once you...
Yes, I like it. Extreme outliers and the outliers. It was very new for me.
Okay, yes, and you will see also in your data. Once we apply that explore option, you will definitely, you will be able to make out the extreme outlier and the normal outlier. And again, now the question is, now what to do with these outliers? So now there are various options we'll discuss. So there are basically 3 reasons for the outlier. There could be data entry error, like while entering the data manually, if you have given your data sheet to enter someone, or even if it is on the tab, someone has by mistake entered it abnormally high or abnormally low. So that could be one reason. The second reason could be measurement error, like the tool or the, sometimes if the trainer, if the interviewer is not trained, properly, he or she may be not able to take the interview properly if it is measured on a Likert scale. And normally you will see that if somebody else is taking the interview, he tends to go down in the middle, like strongly disagree or strongly do not disagree or agree. So mostly what that person does, it's to go in the middle value rather than taking the extreme value. So that way there won't be any measurement error. But like if the tool, weighing machine, or if it is a biochemistry department or the pathology, there are various departments. If the machines are not calibrated, many times you will have the sample and test result where you won't believe that, there must be some error with the machine, where you send a sample again for the rechecking. So there could be measurement error by that particular tool which you are using to test your data, or there could be genuinely unusual values, right? So there could be 3 possibilities. Either it is a data entry error, or it is a measurement error, or it is a genuinely unusual high or low value. Now, what should we do with the outlier? So there are 2 ways. Either you can remove those outliers. Like if you are having data like 4 or 5 outliers and the serial number which you have seen, you may remove those 5 data from your analysis. The important point is you should mention about the outlier in your data analysis, that upon testing for the outlier, you got 5 outliers, and now what you did with the outlier, that also you have to mention. So normally, if you want to keep the outlier, there are various ways. If there are many outliers, definitely then you need to apply a non-parametric test, like non-parametric counterpart of this one sample t-test. I mean, I'm telling you, not the independent sample t-test is the Mann-Whitney test. And we have to modify this outlier. If you want to modify this outlier with a less extreme value, then also you can modify this outlier. Means you can take the second lowest or the second highest value. So you can replace that with this value. The third option is to transform the dependent variable. That in the transformation of dependent variable, either you can transform it logit transformation, or you can do the Z-score transformation, or the safest and the important option is include the outlier and run the analysis. Because these one sample t-test, independent sample t-test, they are the robust test, and they are not usually affected by the few outliers. But again, if the outliers are many, as you will see in your data, then you need to put a non-parametric test. So this is the way we report the outlier. So normally, if the data set is very large and you have got 4, 5, 6 outliers, then it doesn't affect the analysis. But if your data is small, like if I've got 30 sample, 35 sample, and if you've got 15 outliers or 10 outliers, then you cannot remove those outliers. Then you need to perform the non-parametric test. But the important is to acknowledge the outlier in your analysis or in your statistical analysis. I know whatever you write in the manuscript, it is important to report the outlier. So always report the outlier, number of outliers, and what you did with those outliers, what method you applied. So that is important. So this is again the same like we did for the normality. We check for the normality. You should check for the outlier also. So this we discussed. So now coming to the null and alternate hypothesis. So null hypothesis in case of a one sample t-test is that the population mean which we have estimated from the sample mean, it is equal to the known population, or the population mean which we have calculated from the sample, it is not equal to the population mean. So this is, I'm sorry, this I have by mistake, it is written null. This is the alternate hypothesis. So this is the null and alternate hypothesis. Now coming to the how we do this. So I'll show you. First, you have to go to this is my independent sample t-test, and I have to see the question which I have to perform is, to test is, this is the demo question, that the mean systolic blood pressure of, I have to check whether the mean systolic blood pressure of my sample population is different from the population mean or not. So the mean systolic blood pressure of my district is 120 and the mean systolic blood pressure of the state is 140. And I have to check whether the sample population mean, the sample mean, is it different from the population mean or not? So this is the question. Now, how to answer this question? So you have to go, there are various options. So we will be using this analyze option, descriptive. In descriptive, come to the explore. So there are various assumptions, you know, for what test we will apply here. Since this is a continuous data, this is a single variable. We want to test this variable against a known value. So I'll apply one sample t-test. But before I apply one sample t-test, I need to test for the assumption. So the second assumption was data should be normally distributed and there should be no significant outlier. So I'll click this explore button. So in explore, I have to check for the systolic blood pressure because that is the parameter which I have to test. Now here you will see the statistics and plots both. This option we have used in the descriptive also, where we have used only the statistics part of the command. Here we will use only the plots because we have read that we will be using the QQ plot and we will be using the normality testing, that is the Shapiro-Wilk. So if you click on this plot, uncheck this stem and leaf and check this normality plot with the test. So this normality plot with test will give you the value of Shapiro-Wilk and it will give you the QQ plot. Then press continue and press OK. So you will see that it will give you an output. That output, it is the first will tell you the overall summary. And then this is the normality. The value of Shapiro-Wilk, what is the value of Shapiro-Wilk here? It is 0.166. This is the value of Shapiro-Wilk.
One more thing I want to ask. Ma'am, one more thing I want to ask over here.
Yeah, please.
Ma'am, I want to ask something, that is it hard and fast rule that we can only use chaperone when the sample size is 50? If it's more than 50, still we cannot use chaperone test.
Yes. If it is more than, you will see that. If it is more than 50, many a times it will show that data is not normally distributed. The value will come as a significant one. So we don't want the value to be significant. So the Shapiro will is sensitive only for the low data. If the sample size is high, and if you comment on Shapiro will, you will not get the right answer also, because you will automatically see this. In every test, I will show you the comparison between the Shapiro-Wilk and QQ plot, and you can yourself see. So here in this case, if you see the Shapiro-Wilk, then what is your interpretation? Is the data is normally distributed or not normally distributed? Ashish?
Okay. Yes,
can you answer this?
Yes, ma'am. Ma'am, right now, yes, ma'am. Right now it's coming non-significant, so it's normally distributed.
Okay, so non-significant, so it is normally distributed. So if you come down, so other participants, is it clear why this p-value more than 0.05 is, we require that? We don't want p-value to be less than 0.05. Is it clear to everyone? Pawan is writing yes. Okay. Okay, Pawan. Yes, sir. Okay. There is network error while explaining command. So should I again, Shamima is writing. Okay. I'll again explain the command. Although we will run these command many times, but still I'll show you. So you go to the data. Go to the data, and I forgot to explain the data also. Let me explain that data sheet. So come to the variable view. You can see here that it is the ID of the patient, age of the patient, gender, race, socioeconomic status, BMI category, myocardial infarction order, where the 1 is first order and 2 is the recurrent order. You can see it from the values. And then this is the systolic blood pressure, diastolic blood pressure. TP is the total protein level. If you increase this, you can see the full description of this label of the variable. SGOT, sodium level, potassium level, LDH. Since all these are the scale variable, you can see here it is all the scale variable. These all are the nominal variable. So I have to change this. So yesterday also I changed this. This is actually an ordinal. BMI category is also an ordinal. And then again, other one are nominal. And this is, if you come to the data view, you can see the data here. So in the data, if I want to check for the normality, I'll go to the analyze, descriptive, explore. Remember, analyze, descriptive, explore. In the dependent, you have to move the SPV because there is only one variable which we have to test. So we will move this variable to dependent list. I don't want, initially when you click this, you will see this both by default checked. But I don't want statistics now, because statistics, I have tested this in the descriptives also. While telling you the descriptive statistics, I have told you that statistics you have to check for all the mean, median, mode, interquartile range, trimmed mean, kurtosis, skewness. So I'm assuming that you have checked for the statistics. Now I have to check with the plot, normality plot. So what I'll do, I'll check this, plots, and then I'll go to the plots. In the plot option, by default, this stem and leaf is checked, but I don't want this stem and leaf because we don't use this. So basically what we use, it is the normality plot with test. That is the command which we use for in SPSS to test for normality, then press continue and then press OK. So if you press OK, again, the repeat output will come. This I was showing you about the significant level. And if you go down, you can see the normal QQ plot. So can you see this? All the values, they are along this diagonal line, very much close to the diagonal line. That means the visual inspection of the QQ plot shows that the data is normally distributed. right? And this is the box plot, which you need to see and comment on the outlier. So can you see any outlier here? Please answer yes or no in the chat box, or you can say, so yes, it is, there's no outlier here because you cannot see neither a circular dot nor a asterisk. So there is no outlier, right? So now what is my, as I have met all the three assumptions. I have met the assumption of a continuous variable, which is my systolic blood pressure. I have met the assumption of there is no significant outlier, and the data is normally distributed as seen by the visual inspection of the QQ plot. So now I'm ready to apply the one sample t-test. Now what is the command for one sample t-test? So go to the analyze, compare means. So here you can see this one sample t-test. So is it visible to all of you? Now from now, for today's session, we will use this command, compare means, and in descriptive explore. These are the only two commands which we will use most commonly. So go to the one sample t-test, click this. Now you can see here that the test variable. So what is my test variable is the systolic blood pressure. Now I have to compare this with some known standard. So known, what was that? It was 120 for the district and 140 for the state. If you see the question, so I have to test for the 120, it was for the district, and 140 was for the state. So what I'll do, I'll go back. So this was the command. I will write here as 120. So that is the difference here, because in proportion you were testing, you can test 2 or 3 proportions simultaneously. Remember one sample where the goodness of fit, we tested 3 proportions, 40%, 30%, and 10%. But here only single mean test value you can check. You go to the option. So option, you don't have to do anything, and then press OK. So when you press OK, you have this one sample statistics. This gives you the value of T. This is the degree of freedom. This is the significant level, two-tailed.
Why are we taking 120? Why are we taking 120 in the test value? Why not 150?
Because there were 2 questions. I have to test, like if I want to test it with the comparison of my district mean. So my district mean was 120. So I'll perform 2 tests now. I mean, I'll do it twice. At one point of time, I'll test it with 120. Okay. And on second time, I'll put 140 because I want to compare it with my district mean, and I want to compare it with the state mean. This is just to show you.
Okay, ma'am. So right now we are comparing with district mean, right?
Yes, yes. Instead of putting 2 questions, we have just, same question, because same question, only the reference value or the, against which we have to test is different. That's why I have only put the 120. Is it clear now?
Yes, yes, ma'am.
Okay. So this was the degree of freedom. This is the significant two-tail. So I hope all of you know what is this two-tail. Once two-tailed will be, it can be more than the my test mean, means my sample mean can be less than the hypothesized or known mean, or it can be more than the hypothesized or known mean, right? So if I'm going both ways, I don't know now whether it will be less or more. So I'm go with the two-tailed significant. And this is the mean difference. Mean difference, because you can, if you see the descriptive, you can see here systolic blood pressure. The standard here, the mean is 143. The mean of my sample is 143, and the mean which against which I have tested it, it was 120. So there is a mean difference of 23.86, which was significant. And if you see the value of lower and higher confidence interval, then you can see that it is towards positive side, both 19.4 to 28.3. So even if you don't see this significant level, you can comment by just seeing the confidence interval that it was significant, right? So this, how will we enter this in our interpretation? So I'll show you simultaneously. how to do that. And this was the table. So the APA style table for this would be comparison of a mean systolic blood pressure against a hypothesized value. This is my sample mean, this is the standard deviation, and this is the mean difference with the confidence interval. The statistical, the value of t is 10.5 with degree of freedom 192 and the p-value is 0.005. So now I would request one of you to read this interpretation for me. Ashish, since you are talking today, so can you do this for me, for us rather?
Hello?
Yes, Ashish,
Hello?
you are audible now. Yes, you are audible now.
Yes, ma'am. I have to just read this interpretation over here, ma'am.
Yes. It is written, you just have to read it.
Okay,
Can you
the
see
values of systolic blood pressure? Yes, ma'am. The systolic blood pressure was normally distributed as reported in the QQ plot to test the normality. A one sample t-test was applied to test whether the mean systolic blood pressure of your sample differs from the district mean. We observed a statistically significant difference in the mean systolic blood pressure of study sample from hypothesized population. P-value 10.5, degree of freedom 192, p-value less than 0.005.
So is it clear to everyone, to all of you? Or any ambiguity up till this point? You can apply that, that is written here, QQ plot. You can also write one sentence that there was no outlier. I am just adding it. There was no outlier as seen by the visual inspection of the box plot.
Ma'am, I want to ask a question.
Yeah, please.
Ma'am, is it necessary to calculate mean against some value? Suppose two groups are there and we are calculating their means. So that can be done by a simple statistical test, no? So is it necessary to just say, like you have mentioned 120? So we can simply write that mean systolic BP in this group was itna and mean systolic BP in other group was itna. So is it necessary to take a reference value?
Actually, the question, Priyanka, which you have asked, if you have got two groups, we are going to read that again in the next session. That is the independent sample t-test. Because it depends on your research question, right? It is not necessary. Everything, all the statistical analysis are guided by our research question or our objective. Like if, many times like we are in community medicine or like we did yesterday for the goodness of it, if some known mean is there and I want to test my sample mean with that known mean, then only I'll apply one sample t-test. It is not a very commonly done test. Most of the time we do the independent sample t-test or paired t-test, right? But because this is again one type of t-test which we can use if we are asking or if we have objective of such sort in our research question. There is no term or the concept like necessary. It is only the type of research question which will answer what type of test we should apply. So if you have got two group, we will do this in the next session. Then we'll apply the independent sample t-test. But there is something known as one sample t-test also, which we apply when we have got only single sample. Like if I'm doing something on my MBBS students, right? If I do a BMI of my MBBS students, like yesterday you have seen that we have categorized them into 40%, 30% and 10%. But I don't want to compare the proportion. The mean, suppose the mean BMI by this NFHS from all over India, we know that the mean BMI of Indian population is 23. And if I have selected a sample of the MBBS students and I want to know whether this group is different from the all over India or all over state or all over district or not. But it depends on the research question. If you don't want to do this study, then you need not apply this one sample t-test.
Thank you.
Is it clear, Priyanka?
Yes, ma'am. Yes, thank you.
Most commonly, we don't do it. That's why you will find it a little bit, new, or you must not have, done it repeatedly. But this is also one option where you can test this. It is right that like goodness of fit, we don't do it very commonly. Most of the time we do it the chi-square test of association. But you should know that something of this exists. It is mostly done in business, this one sample t-test, client or the sale, something like weight of the biscuit packet, if it is 50 gram, and if you find it that it is 48 gram and something like that, you have to test it. So most of the time it is done in business, in the marketing. But this is also a concept which exists in health also, where if needed, you can do it.
Okay, thank you.
Okay. So is it this one sample t-test, is it clear to everyone? When will we do this? What is the need? So I'll go to the another one, that is the 140. So what I'll do, compare. What should I click? One sample t-test. Then this SBP will be same. Instead of 120, I'll do 140, which was my state mean. And I have pressed OK. So you can see here that this was not significant. You can see the significant level was what? 0.08, which is more than 0.05. You can see the mean also 143. So the mean of my sample is 143 and against which I am testing is 140. So there's a difference of only 3 millimeter of mercury. And here also you can see it is 0.6 to 8.3. So that one is there in between. So that's why it is not significant. The confidence interval also tells you that it is not significant. And you should, here it is given the exact number of p-value, exact value. So you should report ideally the exact p-value in your analysis. You should not write less than 0.05 or more than 0.05. Yes, Praveen is writing just a query. Pardon? Praveen is writing, yes, t-value is important. Like you write the chi-square value and the degree of freedom. So it is important to write t-value and degree of freedom in research paper. You should. So if you
one more go here.
Yeah, Ashish.
Like when we just calculate just like about all ratio risk, we see that it is one in that confidence interval and it's non-significant. But ma'am, I don't know. I just attended a workshop just before this workshop. We were saying that if, in case of TS, there is 0 in the confidence interval.
Actually, Ashish, you are not clearly audible. You are not clearly audible. Voice is breaking in between.
Am I audible now?
Yes. Can you repeat the whole thing? Hello, Ashish. We cannot hear you. So if I think there is some problem, you can type in the chat box. Okay, once he joins us back, then we can solve his query. So till that point, so we'll just see how to write this result of the second one. So this was the second one where we have tested it against this 140. Ashish, oh yes. So this, you can see that the mean difference is 3.86 with this is the difference 0.60 to 8.33. So can anyone read this for us, this interpretation?
The values of systolic blood pressure was normally distributed as reported in visual inspection of QQ plot to test the normality. A one sample t-test was applied to test whether mean systolic blood pressure of your sample differs from the state mean. We observed difference in mean systolic blood pressure of study sample and hypothesized population was not significant. The t-value of 1.70, degree of freedom 192, and p-value of 0.089.
Okay, so thank you, Priyanka. I think Ashish is not able to see the screen, but I think is the screen visible to all other participants?
Yes, ma'am.
Okay, so like he's writing, ma'am, in case just put that. In case of t-test, if confidence interval has 0, then would it be considered non-significant? Oh, actually, I got your point, Ashish. You are confused between a confidence interval of 0 and confidence interval of 1. So when it is a difference, then the 0 is significant. In fact, then the 0 should not come in between. But if it is a ratio, like odds ratio, here also you are seeing it, t-value, in that case, the 1 should not come in between, right? So in this case, since it is a difference, this is a mean difference of 95% confidence interval, so that 0 should not come in between. It should be either towards plus side or it should be either towards the minus side, right? Less than 0 or more than 0. So you can see here that
if 0 is coming, then it's non-significant, right, ma'am?
Yes,
if
if
0 is coming, then we can.
Yes.
Yes,
In case of a ratio, it is 1. In case of a difference, if 0 comes in between, it is not significant. Okay.
Okay. Ma'am, and also in linear regression, we also say that if 0 is coming in between, then it's also non-significant, right? In linear regression.
Yes, we'll do that also. In that also, so it depends whether you are comparing it in terms of a difference or in terms of a ratio. Then that it changes from 1, 0 or 0 or 1. That, value of confidence interval. So if any query to anyone, Ashish, can you see the screen now?
Yes, ma'am.
Okay, if yes,
I can see the screen, ma'am.
Okay, so thank you. So if yes, then I think we will break for the breakout room for the independent sample, this one sample t-test.